Hey guys, hope you're doing well. In the previous video, I showed you the demo of the app. So now let me show you the structure and the all the tools that I've used to create this app and how this is actually working and what are the requirements that I have taken, what are the evaluation, the front end, the back end, the whole system. Let me show you one by one. So let's start with the structure. Over here, you can see this is my structure over here, which has the app folder and the uh, inside the app folder we have the core folder and the rack folder. The core has all the environment initialized inside the config.py. You can see it has been initialized over here, and also we have the rag folder over here, which has in the chat.py we have initialized the LLM. In data ingestion we are taking it in the PDF file, and using chunking and an embedding we are transforming it to vector database. And then we have the rag pipeline over here, which is orchestrating the data ingestion, the retriever and the chat together. And this is the retriever one, which is retrieving all the relevant data which is there in the database, the vector database. This is the rag system, and we are using front end, the Streamlit over here, and FastAPI as the backend API orchestration, right? So Chromadb is the vector database that we are using, and over here this is the database file, database inside the app where we are saving the PDF file. We can save multiple PDF files over here. Once you upload that inside the app, it will come through and be saved over here. I have also containerized each the API and the front end using Docker. So created an image for the API and the front end as well. And using Docker Compose, we are running both the API and the front end. And there we are using RAGAS for the evaluation. And the evaluation metric that we have used is being uploaded inside my GitHub repo that I have also already mentioned. So let's go through the app. So inside the environment file, I have added my Groq API key and my model name. So I have initialized that environment over here. Now I have loaded the environment inside my Python file over here inside the config.py. You can see I have called the Groq API key from the environment. I have called the model name over here. Now going to the main RAG model over here, first I have initialized the chat model. You can see LangChain, from LangChain Groq, I have initialized the chat model and added the model name, added the API key, given temperature as 0 because this is a specific task that I wanted to initialize, because the chats over here is reading and summarizing the data from the PDF file. So in that case, uh, we want we don't want to be more creative in the sense that we don't want the LLM to be creative. We want the exact data and the response from that. So the temperature is kept at 0, and we are generating the response over here. So this is the basic chat um, initializer over here. Now, if you go to the data ingestion, where we are going ahead and ingesting the data, the PDF file inside the vector database. So firstly, we are reading the PDF file. I have used PyPDF directly loader from LangChain, and once I loaded the data, I have went ahead and used recursive character text splitter. This is a um, LangChain text splitter we have over here, and we have broken it down into different chunks. The chunk size I have kept at 1000 and chunk overlap as 200, because once we were evaluating inside the RAGAS, then what was happening when I have tried with 300 chunk size, 500 chunk size, and but the 1000 chunk size gave us the best metrics over here. So that's why I'm using this one. Um, Then we are saving it each of the chunks inside variable called chunks. Now the embedding, before we were using an embedding called all LM and V6. So in that embedding, uh, the evaluation, once we were doing the evaluation, the metrics were not correct. So it was very low. So we went ahead and used BGE large over here. Before BGE large, we used BGE small. Then again, it was better than all LM, but still uh, there was some differences over here. So we went ahead with BGE large, and we initialized the embedding model over here from the HuggingFace, and after that we initialized the Chroma database that we are using for our vector database over here, and we give the embedding function, we give uh, the collection name and the directory, persistent directory over here, and we have added the documents which are the chunks over here. So this is the whole data ingestion, and it is being embedded. Yeah, the PDF is being chunked, then it is being embedded to a vector and being saved in the vector database. This is the whole concept of this data ingestion. Next, let me show you retriever first, because we are retrieving the relevant data from uh, the vector database. So now the from the Hugging Face embeddings, again we are using BG large because we need to keep the embedding as same. So for the retrieval one, what we are doing, we initialize the embedding over here, and we initialize the vector database. Now we are searching the vector database as a retriever, and the Chromadb, we will be searching it with the similarity search, and search keyword arguments is 3. That means we will search for a similar chunks, top 3 similar chunks for the inquiry that we are retrieving, right? So this is how we are searching, and once we retrieve the top 3, it will return it back. And inside the rack pipeline, we are all orchestrating everything over here. You can see we are generating the response, we are retrieving the data. So I have called all the model that we have created, and we have created a basic memory function. Later on we will try on and add a memory function using other databases, but right now it's a basic chat memory where we can have maximum of 10 entries, 10 chats saved over here. Now going down, you can see this is where everything is working. We are asking the question. Once we input a question, a query inside the app, it will go ahead, it will retrieve the documents, right? It will retrieve all the query documents, the top 3 documents, as I mentioned, inside the retriever. It will go ahead and save it over here, and then we will be able to, we are joining all the top 3 documents inside mm, a variable called context. And again, we are initializing the memory context that we have enabled over here for all the chats, and then we have created a prompt. This is a basic prompt, but this is working wonderfully, as I have shown you in the demo. um, you can see I have initialized, you are an AI assistant responding to a question. Use prior conversation memory to keep continuity. Only provide response to the question provided. Previous conversation, you can see I have given the memory context. It is the saved memory that we have, and for if the memory context is blank, I have given as or none, just so that it doesn't cause any error. Uh, then we are initializing, giving it the context. Context is the relevant data that we are fetching from the vector database, and the top 3 chunks that we are retrieving from the vector database, we are going ahead and sending it over here inside the context. And the question, that it is the query that is being sent inside the input of the bot, is being added over here. So these are all the full form, the prompt that we have created. Now we are going ahead and generating a response. So in this response, we are calling the generate response function, which is the LLM function where the whole prompt will be sent to the LLM. LLM will then go ahead and create the required response, and then it will send us back in this format over here, which will have the question as question, answer as response, context as context, and memory as memory. So this is how it will be returned to the backend of our app over here. And we are appending all the memory, the response that is coming from the LLM inside the memory over here. But then again, after the max memory, like if 10 chats is fully filled, then it will go ahead and remove the topmost chat memory. Like if I said hi to the chatbot over there, then what it will do, it will remove the hi, that is the first one that we have memory that we have stored inside our memory. So it can have the relevant rest 9 memory available to it, to the LLM, so that we can send it once again and add the latest memory back in over there. So this is how we are orchestrating the memory over here, removing the topmost memory over there. Now this is how the pipeline is working. So this is the backend of the RAG. Now coming to the let's go to the FastAPI. So we are orchestrating using FastAPI. You can see I have also called our module over here, the ask question, chat memory, and data ingestion, and we have imported FastAPI and base model. So initialized FastAPI, we have created the base model class over here with the question, and for the home over here, we are just returning and checking if the API is running successfully or not for the home over here. Now, next part, I have initialized this slash data. The slash data, what it does, it is sending the uploaded PDF file, and it is being called, and data is ingested inside. It is the PDF is chunked, PDF is embedded, then the PDF, the embedded part is saved to the vector database. Over here, we are using the Chromadb database. So this is the pathway that is used to ingest the data. Then comes the chat path. So inside the chat path, we are sending the question, the input question that we are sending from the front end. I will show the front end over here in some time. So now it is sending the question or the query, and then it is sending it to the function ask question, and then with all the context and all the relevant responses, it is sending it to the LLM, and then the LLM is responding back, giving us a result, and we are sending the result back to the front end. So I have given a memory reset function over here, so that we can reset the memory manually if we want to totally clean out previous chat memories. So that's one of the functions that I've given over here inside the API. And for the memory, we can call this memory function to return all the memory available in this session that we have used, right? So yeah, this is the backend of the API. Now coming back to the front end, you can see I am using Streamlit, and inside Streamlit I have the file uploader over here. Right now, as I mentioned, I am just keeping it for PDF. Later on, I will update it to different file format. Right now, we are using only PDF. So coming to that, and next one is we are saving it to the data folder over here. If you upload any different PDF file, multiple PDF file, all the PDF file will be uploaded over here. And then add to knowledge, what it does, it goes ahead and requests the data which is present inside the data folder over here, all the PDF. It will go ahead and ingest the data, and you can see we are using the slash data that I just shown you over there inside the FastAPI. and it will go ahead, ingest the data. If it is successful, it will show knowledge base updated. If not, it will show the error response over here, right? Now, after the ingestion, we can go ahead. This is the chat input where you can go ahead and chat with your PDF file, summarize it. And over here, you can see we are using the slash chat function over here, slash chat URL. And in this URL, if the response is okay, once the request, we are requesting the query, and once the response is coming through, if the response is okay, then it will be responding to the answer, or else if there is an error, it will show the error, what is the error which is coming through over here. And same, we are also updating uh, the content over here inside the chat message, um, like there is a user role, there is an assistant role, the AI is the assistant role, so that once we add our chat input inside the app, it will be updated as a user input, right? That is also updated over here. If you can see over here your question, and it will be appended as the role user, you can see, and the content as question is being updated. Now, if the response is coming through, you can see it is being updated as an assistant. So this is the response that is coming through. So both the role are uh, differentiated perfectly so that the chat can easily be viewed, like what is the question that I have added and what is the response that I'm getting back over here for the role itself. So yeah, that's for the front end. And yeah, as I mentioned, this is the database which we are saving all the vector for the PDF file. This is the data, the PDF that we are saving in, and we have the environment file. And as I mentioned, we have created the Docker API image file over here and Docker front-end Streamlit image file over here. And we are all orchestrating it using the Docker Compose file, creating two services, the API services and the front-end services, um, which is working independently, but the API is connected to the front end so that whenever any button click or any action is done in the front end, it will go ahead and the action will be triggering the URL, and we will be requesting it via API, and the API will itself send the data back to all the module and the functions that has been created, bring back the response to the API. API response will be given back to the front end, and this is how all the process is working. So there are multiple requirements that I've used. We are using LangChain community, Chromadb, PyPDF, uh, .env for environment, text splitters for chunking, UVcorn so that we can initialize our FastAPI over there. You can see FastAPI, Streamlit for front end, datasets for evaluation in RAGAS, again RAGAS for evaluation, LangChain Groq, and sentence transformers. I have kept it as it is because beforehand we were using the embedding all LM v6. It was inside the sentence transformer, so I initialized it inside the requirement. But it's where we can remove this, no worries. But I've kept it as it is just for a reminder that the sentence transformer that we were using all LM v6 wasn't correct and wasn't working correctly over there. Anyways, coming back to the final one, the evaluation. So inside the evaluation, uh, we have imported data set. We have imported evaluate from RAGAS, and LangChain community embedding that we have also called back the HuggingFace embedding over here. And inside the RAGAS metrics, we are using faithfulness, relevancy, precision, and context recall, right? So here are some of the data evaluation question that I have added over here, which will go ahead and find the exact relevance, exact faithfulness, and exact precision recall over there. And then again, I have called back the ask question from the RAG pipeline, which is orchestrating all the RAG setup. Now, one thing to mention why I am using Groq, LangChain Groq. I initially started using Groq directly, but then again, I had issues with uh, RAGAS for evaluation. RAGAS actually doesn't allow uh, direct Groq implementation. It needs to be wrapped around a LangChain wrapper for the LLM. So we can use Groq directly and then use the LangChain wrapper for that LLM to wrap it up and then use the RAGAS. But then again, what will happen? It will cause issue inside the. It was causing, it was slowing down the app very much. So I went back to LangChain Groq chat, and then I have seen it is working very fast. The latency is not that much. So now for the embedding, you can see LangChain embedding wrapper. We will be wrapping it up. You can see inside the BGA large model, we are wrapping it up using LangChain embedding wrapper. And data sets we are sending the data set and adding all the questions, appending all the questions, and appending all the answers, the context, and the ground truth. And then we are sending all the details back to the metrics to evaluate, and we are evaluating everything. So the evaluating metrics that I'm getting, all the details that I'm getting, I have already uploaded that metric over there inside my GitHub repo. And yeah, that's mainly it. Let me know your thought, guys, and any question, let me know. Thanks.